I hope you're ready for some more math today. We're going to be evaluating algebraic expressions. So make sure you have some toothpicks, popsicle sticks, even straws cut in half will work for this activity. So grab your supplies and jump back in and let's get started. Start here. So go ahead and grab your either toothpicks or popsicle sticks or straws, and we're going to start with one of them. So you see one right here. Now we're going to be making some squares with our toothpicks, or in my case popsicle sticks. Now how many more would I need to add to my one to make a square? Let's do it. 1, 2, 3. So my expression, I started with 1, right? And then I added 3, didn't I? And how many squares did I make out of my 1 plus my 3 more? Just 1. How many? I have toothpicks up there, but I'm using popsicle sticks, so I'm going to change that. How many popsicle sticks? How many popsicle sticks? How many popsicle sticks did I use? Great, 4. All right, now what if I want to add onto my square to create another square? How many would I need to add to this? 1, 2, 3 more, right? Do you see 2 squares now? So now my expression is going to be 1 that I started with. I added my 3 for my initial square, but then I added 3 more. So I can multiply my 3 by 2, can't I? What's 3 times 2? 6. Add 1. 7. Do I have 7 popsicle sticks here? I certainly do. How many squares do I have now? 2. Okay. Now, what about if we wanted to add another square? How many popsicle sticks would I add? 3 more, wouldn't I? So now, again, I started with my 1. I added my 3, but how many groups of 3? I have 1, 2, 3 groups of my 3, right? So I'm going to multiply my 3 times my 3. How many squares do I have? I have 3 squares. How many popsicle sticks did I use? I can even solve it here. I can count them, but let's solve it. 3 times 3 is 9. Add 1. That's going to give me 10. I wonder if you see some patterns already. So I'm going to remove my popsicle sticks now. I want you to really look to see if you see a pattern. What if I said, you know what, we're going to do 4 squares without actually using the popsicle sticks now? Can you figure out what our expression would be? Hey, you may have drawn a relationship here between the fact that I multiplied it by 2, I multiplied it by 3, that gave me 2, that gave me 3. What might I do for my next one? Yeah, I had my 1, I added 3 to it, but to get 4 squares, I need to multiply that 3 4 times, don't I? And how many popsicle sticks would we have if I wanted to create 4 squares? Well, 3 times 4 is 12, plus my 1 is going to give me 13. Do you see a pattern over here too? Yeah, you may have noticed There's 3 in between each one, right? And we are adding an extra 3 each time. Okay, what if we jump to 5? I bet you can do this one all by yourself. So go ahead and figure that out all by yourself and then jump back on. So you probably got 1 plus your 3 times 5, right? And it gave you 16, or you needed to use 16 popsicle sticks. All right, now what if I said we are going to create 22 squares? Now that you've seen your pattern, you would know how to do this, right? Your expression would be your 1 plus your 3 times how many? Great, 22, because we wanted 22 squares. How many popsicle sticks would we use here? Yep, what's 3 times 22? 66, plus 1 more would give us 67. We did a big jump there, didn't we? So now we can actually incorporate an algebraic expression here. What if, let's see, I'm going to erase this bottom one so we have some space here. What if the number of squares was n? In other words, we're not sure how many squares, but we're going to use our algebraic, or our variable, I should say, of n here. What would be our expression? We would have our 1 and our 3, but we don't know how many squares, so we would multiply that by our n. Do we know how many popsicle sticks we would use? No, we don't, because we don't know what n is. So that would still be a question mark unless we knew what n was. So you can see by using algebraic expressions, it will help us find these unknown numbers. All right, let's do some evaluating now. So we're going to evaluate the following expressions when x equals 5. Okay, so when it says x equals 5, we're going to literally plug in 5 where we see x. So in this expression, our x is going to become our 5. We're going to add 3. What would our sum be? Great. Be 8. All right, let's do this one over here. So I have my 3, and I'm multiplying it by my x, which is 5, over 5. As I work through this, I will get 15 fifths, which also equals, yep, the whole number of 3. See how easy that is? Let's do these two. Evaluate the following expressions when p equals 8. All right, so we're going to plug in p here. So or plug in 8 for our p. So we have 3/4, and we're multiplying it by our p, which is 8. You can also write as 8 over 1 if you would like to. We can simplify, can't we? 4 divided by 4 is 1. 8 divided by 4 is 2, which gives us a final answer of 3 times 2 is 6 over 1, which is going to give us 6. All right, let's do this one. I have 5/10, and I'm multiplying it by my p, which is 8. Do you know how I like to look at this one? And you probably have done this too. 5/10 also equals 1/2. So if I take a half and I multiply it by 8, 8/2 equals 4 wholes. So this one you can probably do mentally in your head instead of something like this when you're trying to work through it more like an algorithm. Just think about it. Think what 5/10 equals. It equals 1/2. Talk through it, and that's going to help you find that answer a little quicker and a little bit easier. Let's do a few more. Let's evaluate the following expression now when n equals 4. Okay, so we're going to plug it in. We're going to recopy down our expression here. And then we have 3n, so we have 3 times our n, which is 4, over 2. Okay, which also equals my 15 minus 3 times 4 is 12 over 2. You probably already have the answer, don't you? As we also know, equals 15 minus 12 halves is going to give us 6. 15 minus 6 is going to give us a final answer of 9. So slowly work through it. Please do all the steps so you don't miscalculate or miss a number here and there, but really work through it all the way through. All right, now we have x equaling 1/3. So we're going to evaluate this expression now when x equals 1/3. So I have my 1/2, and I'm going to multiply it by my x, which is 1/3. And then I'm going to add my 3. Okay, so as we know, order of operations, we will do this first. I'm going to work through it right below. 1/2 times 1/3, or the product of a 1/2 and a 1/3, is 1/6. And then we're going to add our 3. A 6 plus 3 is, great, 3 and 1/6. All right, we're just going to do one final one. Now with this one, my suggestion is first to rewrite this. Remember how we talked about how we can also write this as 3/4 x. So you're going to get the same result, whether you write it 3x over 4 or 3/4 x. Because we can see, for example, if we plug in the number 2 for x, we're going to multiply our 3 and our 2 together and then divide it by our 4. Whereas over here, the same thing. When we multiply it like this, we're going to write our x like 2 over 1. And 3 times 2 is 6 over 4. So we would get the same result. So we can write it a little bit differently. And now this is going to help us plugging in our 3/5 for x. So now I can take my 3/4 and just multiply it by my x, which is 3/5. Now again, as you know, we just multiply it across with our fractions. 3 times 3 is 9. 4 times 5 is 20. Did you get 9/20ths? Now there's another way you can also do it, and this may feel a little bit longer, but your brain may work through it a little bit easier this way. We would write our 3x over 4 as 3x divided by 4. Okay, we can see it like this as well. And then plug in our x, which would be 3 times 3/5 divided by 4. Okay. Now again, multiplication and division, when they're both in our expression, we go left to right. So I'm going to solve this first. 3 times 3/5 is going to give us 9/5. So now we're going to take our 9/5 and divide it by 4. Okay. And we know dividing by 4, we could also multiply by 1/4, right? If we divide it by 4, we're looking at 1 out of those 4. So it also, we can write it as 9/5 times 1/4, right? And we talked about that when we worked with fractions. But 9 times 1 is 9. 5 times 4 is 20. See how we get the same result? 9/20. This one might have felt a little bit quicker and easier, but there are multiple ways you can kind of draw it out and solve it. So I hope you guys had some fun today solving algebraic expressions, and I can't wait to see you back here next time. Bye-bye.